Black holes are cosmic giants that bend the rules of space and time itself. From Einstein's groundbreaking theories to modern quantum physics, we'll explore how these mysterious objects might hold the key to time travel. Let's take a closer look at what happens when you approach a black hole's event horizon, the point of no return. As you get closer, space and time start behaving in really strange ways. Time actually slows down compared to Earth time, something scientists call time dilation. If you were watching a friend fall into a black hole, they would appear to move slower and slower, eventually freezing in place from your perspective. But from their view, everything would seem normal. The massive gravity also stretches everything like cosmic spaghetti. Scientists actually call this spaghettification. Even light can't escape once it passes the event horizon, which is why black holes appear completely dark. This boundary is like a cosmic waterfall. Once you cross it, there's no turning back. Everything gets pulled toward the center, called the singularity, where the laws of physics as we know them break down completely. Einstein figured out something amazing. Time isn't fixed like we thought. It actually changes depending on gravity and speed. Think of space and time as a giant stretchy blanket. When you put something heavy on it, like Earth, it creates a dip. The deeper the dip, the slower time moves. This is why GPS satellites have to adjust their clocks. Time moves slightly faster up there than down here on Earth. The effect becomes really obvious near super heavy objects like black holes. If you had a super accurate watch and flew close to a black hole, you'd notice time moving much slower compared to someone back on Earth. A few minutes for you might be years for them. This isn't science fiction. It's a real effect that scientists measure every day. Now let's explore something even more mind-bending: wormholes. Think of them as tunnels in space that could connect two distant points, like a shortcut through the universe. Imagine folding a piece of paper and poking a hole through it. That's similar to how a wormhole works. These cosmic tunnels might let us travel vast distances quickly, potentially even connecting different times. While we haven't found any real wormholes yet, Einstein's equations suggest they could exist. The catch? They'd probably be incredibly unstable and collapse if anything tried to pass through them. Scientists think we'd need something called negative energy to keep them open. A weird form of energy that pushes things apart instead of pulling them together. While it sounds like science fiction, top physicists are seriously studying whether we could ever create or use these space-time bridges. Let's tackle one of the biggest puzzles in time travel, the grandfather paradox. Imagine you travel back in time and accidentally prevent your grandparents from meeting. This creates a problem. If they never meet, you wouldn't be born. So how could you have traveled back in time in the first place? Some scientists suggest this paradox might actually prevent time travel to the past. Others propose that if you did change the past, you'd create a separate timeline, a parallel universe where your actions happened, but your original timeline stays safe. Think of it like a river splitting into two streams. While this might solve the paradox, it raises even more questions about how these different timelines would work and if we could ever travel between them. Stephen Hawking made a groundbreaking discovery in 1974. Black holes aren't completely black after all. They actually leak tiny amounts of energy, now called Hawking radiation. Here's how it works. Space isn't really empty, but full of pairs of particles that pop in and out of existence. When this happens near a black hole's edge, sometimes one particle falls in while the other escapes. Over time, this process makes the black hole lose mass and slowly shrink. But don't worry, this happens incredibly slowly. A black hole the size of our sun would take about 100 billion years to disappear. This discovery changed how we think about black holes. They're not eternal cosmic vacuum cleaners, but can actually fade away through this quantum process. Let's explore one of the most fascinating possibilities for time travel: rotating black holes. In 1963, mathematician Roy Kerr discovered that spinning black holes might create a special path through space and time. Unlike regular black holes that just pull everything to their center, rotating ones create a unique space called an ergosphere. This spinning region could theoretically let you travel not just through space, but also through time. Inside a Kerr black hole, you might find a ring-shaped opening that could connect to other times or even other universes. The intense spin creates a kind of natural time machine. While this sounds amazing, there's a big catch. The forces inside would likely tear apart any spacecraft before it could make the journey. Still, these mathematical solutions show us that time travel isn't just science fiction, it's built into the basic rules of our universe. Let's explore a fascinating idea: how black holes might connect different times through quantum entanglement. When particles become entangled, they share a special connection that works instantly across any distance. Scientists have found that black holes create intense quantum entanglement effects. This means two black holes could share connected particles, creating a bridge between different points in time. Imagine two black holes as cosmic twins. What happens to one instantly affects the other. Some scientists think we could use these connections to send messages or even objects through time. While we're still far from proving this is possible, the math shows it's not impossible. The challenge is that quantum effects usually work only for tiny particles, and scaling them up to human size would be incredibly difficult. One of the biggest mysteries about black holes is what happens to information and time itself once it falls in. When something crosses the event horizon, the laws of quantum physics say its information can't be destroyed, but black holes seem to scramble and erase everything that falls into them. This creates what scientists call the information paradox. Think of it like shredding a book. Even though the pages are in pieces, the information technically still exists. Inside a black hole, time and space get so twisted that our normal ideas about before and after break down completely. At the center, all times might exist at once. Some scientists think the information might leak out through Hawking radiation, while others suggest it could be stored on the black hole's surface like a cosmic hard drive. While we can't build a black hole time machine just yet, scientists are exploring some amazing possibilities. Advanced civilizations might create micro-black holes in labs, controlling them with powerful magnetic fields. These tiny cosmic objects could potentially be used to bend time in a controlled way. Another idea involves building massive rotating rings that spin so fast they create effects similar to a black hole's gravity. These time rings could slow time inside them compared to the outside world. Some researchers even suggest we could use exotic matter, stuff with negative mass, to stabilize wormholes for safe passage. While these ideas sound like science fiction, they're based on real physics equations. The main challenges are the massive amount of energy needed and finding materials that can withstand such extreme conditions. Let's explore a mind-blowing possibility about black holes and the future of our universe. As black holes continue to grow and merge over billions of years, they might play a surprising role in the universe's fate. Some scientists think that when all the black holes eventually combine into one supermassive black hole, something remarkable could happen. This cosmic giant might trigger a new Big Bang, essentially rebooting the entire universe. The intense gravity could compress everything to a tiny point, similar to how our universe began. While this is still a theory, it suggests that black holes aren't just cosmic destroyers. They might be the seeds of new universes. The cycle of destruction and creation could be endless, with each universe giving birth to the next through these powerful cosmic recyclers. Thanks for joining me on this mind-bending journey through black holes and time. We've only scratched the surface of these cosmic mysteries. If you enjoyed learning about space-time, hit like, subscribe, and share to help others discover these fascinating concepts.